In this session, we are going to see the importance of classes and structures, where exactly we use, and how exactly to use functions inside that, how exactly to declare variables, etc. The classes and structures are very, very important in case of interviews as well. I want to I want to hold some student information, like a student, name is of type string, comma, a student branch is of type string, ID, let a student phone number. Phone number I can go for integer and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, one student is ready here. Another student, B student, B student, B student. Also see here the naming conventions how I am writing. Okay, here either CSE 2, 3, 4, 5, 6, 7, 8, 9, 10. Letter C student, same thing. C student name, ECE, ready. This is clear. To declare, what we did here is for each student we created 3 variables, and we are holding name and branch and phone number. Like if you want to store information about 100 students, you need to declare 300 lines of code. But to refer particular student, it is very difficult. Which student we are referring to? Let's say I want to print a student name information. Similarly, a student name, then branch, then phone number. There are chances of, if you want to compare also, there are chances of typing mistake, and to refer 100 students with the different individual variables, it is very difficult. We don't know which student he is. We have kept name here, like name here. We don't know whether A student is Samba or not, B student is Sridhara or not, C student is DND or not. Instead of calling these, how it will be? DND equal to DND. Pretty simple, right? We're calling with the name itself. If you in the classroom, if teachers calls C student come here, he cannot come. If you call DND come here, it is simple to identify. DND, if you call with the student name, he will come. If you call with the C student, he will not come. B student, he will not come. A student, he will not come. They are in confusion. Who is A, who is B, who is C? So we have to store information about the string. We are having string data. To store the information about the numbers, we are having integer. To store information about the student, there is no data type. There is no data type called student. It is not populating. There is no data type called student to store the information about the student. There is no data type called book to hold the book information. There is no data type called laptop to hold the laptop information. But to hold them, we are having primitive data types. By using them, we can hold. But the problem here is the identity. Identity is the problem. If you simply call a student name is, if you simply call a student come here, it is difficult to understand to the students as well who is A. Even to the teacher also, it is difficult to remember who is A, who is B, who is C. Okay, if you have a name, that is very simple to remember. Okay, so to hold the information about the student, there is no data type, so that we can create a student data type by using class or struct. These are the two different ways to create our own data types. We have seen enum. Enum can hold only one value only. Either weekday means Sunday or Monday or Tuesday or Wednesday. But here I want to create a data type which can hold name, branch, phone number, or anything. The syntax, let me write a student class here. You can go here, you can type class. Let's see struct first. Struct. This is the syntax. Okay, struct, structure name and fields. Okay, let me double click. My new data type is student. Student contains letter name is of type string. We are creating primitive custom data type, but internally we are using regular primitive data types only. Name, branch, phone number is integer. Simple. This is data type. I have created student data type which can hold name, branch, phone number. How to create student here? Let Sridhar is after student. Student. How to create data type is student. Open the braces, open the parentheses. You will see here. It is simply kind of a method. See, variable name, data type, variable name, data type, variable name, data type, and finally which is written in string. Okay, use this method. Here, Sridhar. The branch is, what is the branch? IT. Sridhar branch is CSE. Phone number, some phone number. Sridhar is created by using student data type. Student can hold 3 values. Perfect. Similarly, we can have one more student, Samba. Samba IT. The phone number, what we're having here, the same thing. Let DN ready is after student equal to how to create object. Student name is DN ready. Branch is ECE. Phone number, the same phone number. It is very clear. If you want to call DN ready, you can call DN ready. If you want to know the DN ready branch, DN ready, what is your branch? Branch. DN ready, what is your full name? Let's say name. And DN ready, what is your phone number? DN ready.phone. It is very simple to create and very simple to access. Okay, this is one of the ways to create custom data type or real-time object. These are real-time objects only, right? Student, one person actually. Student is one person, which can be having 3 different fields. These are called fields or properties. These are called properties. Okay, student, these are called properties, and the data type can also perform some operations. What are the operations a student can do? He can do read, write, read, or study. Study is a function. Now, the unit is studying. What I am trying to say here is a student contains properties as well as a custom data properties as well as methods. This is called a method. This is not function. Yesterday we have seen function. The difference between function and method is function is associated with either a class or structure. This is method. Method is associated with a class or structure. Whereas if you declare the same thing here, which is not associated somewhere outside, this is called function, which is not associated to anything. Now this function is, this method is associated with a student. a structure or a class, then it is called method. Here, this is called function. Looks both are same only, but it is part of structure or class. In this case, it is part of structure. So this is called method. Okay, let me create one more data type. I want to hold information about the books. So I can create my own data type called book. There is no predefined data type called book. Start book. Okay, book contains a couple of properties. Let name is of type string. Let author is of type string. Let price is of double. Let three properties are enough. Okay. Now I want to hold the book like Swift book is of type book equal to book contains name Swift reference author let's say Steve and the price is some 399.50. Simple. I have created my own data type to hold books as there is no predefined data type called book. Okay, and I can have one method expose like show detail. I can print the information about the book. The properties what it is having can be accessible here. Book properties only, right? Name, author, price, Okay, how to call that method? We haven't called that method, right? Let me call that method. How to call Swift book show detail. Similarly, you're having student here, right? Student read. How to who is student? Student read. Study. What? Yeah, study method. Student is a structure which is capable of holding properties and actions. Here also, which is holding some properties and some actions. I'm having only one action, but we can have any number of actions. How to create a object? How to create object? Like you just need to use the data type and parenthesis and pass the values for the value variables. Similarly, we created the same, right? Let a int. Assume that I'm creating integer data type of type data type. Here of type book equal to some value. Value here is 1, 2 is integer value. Here book object is book value. This is called object actually. We have created our own data type and created our own object. What happens is here we are creating a book and assigning some values so that here this is called initialize. Basically here the memory is created. Let me create a car object. We create a n number of classes, don't worry. Start car, let brand string equal to let price double something. Okay, now as and when you create a car class, there is no required of memory in the RAM. There is car showroom, car blueprint. For blueprint, there is no need of memory. Let's say if you are constructing a building, we need a plan which is drawn on the sheet. To draw on the sheet, you don't need any land. As and when you construct the house, you need land. You need physical land, right? Okay. Similarly, here a car of type car. Here we are constructing now. We are constructing. When you construct the car, what is that? car, brand. Why it is not coming? Start the car. 1 2 3 4. Something. Nothing is wrong. Car. Car object. I'm creating later. My car is of type car equal to car brand. Sorry, we are giving values here, right? Okay. We can also give you the values. I'll tell you that case is different actually. That is the reason it is not coming. Brand Maruti, price is okay. Here I am purchasing the car. After purchasing the car, to park the car, we need space. This is where exactly space is created. This is actually called memory is allocated. Okay. Once you purchase means creating. You asked the company to give you a car with so and so brand and so and so price. They have constructed a car and given you. Once the car is given to you, you need to have some space to park it. Where this is where exactly the memory is allocated in the RAM. Okay, if you simply create a structure, the memory is not required at all. Okay, in some of the interview questions, they will ask, when they ask in depth, this is what you need to understand. Only when the memory is allocated, only when the object is created. Here we are creating the object. Once you create the object, then only the memory is allocated. Okay. And one more thing. This is how we create our own data types by using structures. Let me create the same thing by using class. See, is there any difference here? There is structure, right? Let me convert that to class. We also created a student somewhere. Class. Okay. Here, we just converted the existing classes, existing structures with the class. See the errors here. Class has no initializers. Here you have simply declared variables, but there are no values here. There are no values here. Okay. In case of classes, what we can do is, let me revert that back. Class, I want to create information about the laptop data type. Okay. Laptop contains brand, which is string, let price double. Okay. In case of class, what we need is we explicitly need to give one method to construct it. By default, it will not be constructed. Okay. In case of structures, okay, we don't need anything. We just need to have properties what it needs. That is enough. In case of class, what we need is either we need to assign some values here. Right. Either you need to assign some values here, or you need to have some method. The method is called initializer or constructor. Okay, we need constructor. For now, what I'm trying to do is I'm putting empty. Here, price is 0. Okay. Let me create my laptop. Laptop equal to laptop object creation. Laptop object creation, because it is already having a values. So I'm just creating with empty. So what happened is one laptop is created with empty name and empty price. To assign values, we can also do this way. My laptop dot brand equal to Apple. my laptop dot price equal to 99,000 something. This is how we can set the values. This is one way. Actual way is this. We need to have constructor which is called initializer. Init brand, you have to have string and price is after double. Now brand equal to brand, price equal to price. Let me differentiate price value. Brand okay. Or else the other way is this. Little confusing. I'll just repeat it. No problem. Self. I'll tell you what exactly is the self. Here, laptop. It is asking for brand. Apple. Price is so and so. At this range, I want a laptop. Okay. The difference between assigning some values here or using initializer is different. Here what happens is when you assign the values, even if you create 100 laptops also, the laptop configuration will be same. Let me remove this for some time. Here brand is Apple, price is so and so. Letter. My laptop is after laptop equal to laptop. My laptop 2, same thing we need to use. My laptop 3, same thing we need to use. Okay, here what happened? I have created 3 different laptops, but actually the values are same only. Let me print and show you. My laptop dot brand, my laptop 3, my laptop 2. The brand is Apple only, but there is a laptop manufacturing company. They will not make all Apple laptops only. They will make different laptops based upon user requirement. In that case, this is not actually useful. So that is the reason we're having initializer here. We're having initializer here. Classes needs initializer if values are not set. Classes, remember, classes needs initializer or constructor when values are not assigned. Okay, in this case, here I have created I asked the company to create an Apple laptop at so and so range. Similarly, I can ask one more laptop with HP at range 54,000. I can ask one more laptop to the company. I want one more laptop of Dell or of range 60. Okay, there is a flexibility. You will not ask the same cars again. You will not ask same laptops again. You will not create the same objects again and again. Based upon your value, you want to create different laptops. This is more flexible. Okay, classes are more flexible. Even structures also more flexible, but there is the difference between classes and structures. Okay, here, any doubts here? Classes and structures are useful to create our own data types. Classes and structures contains properties as well as methods. Here also you can have method. Display. I can display laptop brand. Price. How to call this method? Simple. My laptop. You're telling to the laptop display properties. Similarly here, my laptop 2. Display. My laptop 3. Display. Simple. Apple, so and so price. HP, so and so price. Dell, so and so price. Here, 3 objects are created. Laptop 1, laptop 2, laptop 3. Here, one car is created. If you want to perform any operation on the car, you need to use this object. Here, one book is created. If you want to perform anything, if you want to tell anything to the Swift book, you need to call Swift book, do something. Here, student study, student DND study. If you use DND studies, if you simply use Samba.study, Samba will study. Okay, Sridhar.study, Sridhar studies. If you call DND.study, Sridhar will not be studying. Only DND studies. Any more doubts? Let me take you through the documentation and also show you the differences between classes and structures. In interviews, they will definitely ask between the difference between classes and structures. 100% question. Optionals is 100% question. Classes versus structures is 100% question. Classes and structures are basic building blocks to create custom data types. We have created our own data types because those are not existing. So we have created our own data types. Swift structures have properties and methods as classes. Swift structures have properties and methods. Generally, classes in other languages, structure simply contains properties. In Swift, what it contains, Swift structures contains properties. Those are fields and methods or actions. Other languages, structure simply contains properties, but in Swift structures contains both as classes. Unlike other programming languages, Swift does not require you to create a separate interface and implementation file for the custom classes. You can ignore this. In Objective, this is related to the Objective-C. In Objective-C, if you want to create any class, you need to have 2 files. One is the interface file, another one is implementation file. Here only in single class we can create that. Classes versus structures. Classes and structures in Swift have many things in common. Okay, both can have properties. These are similarities. Properties we can have in classes and structures. Methods we can have in classes and structures. Subscripts we can have in classes and structures. Subscripts we are having separate concept. We teach that. Initializers, even structure can also have initializer. Even structures can also have initializer. Classes and structures can be extended. Conforms to protocol. These are the similarities which you need to remember. I'll tell you in practical as well. Apart from that, classes has additional benefit which can allow inheritance. We'll see typecasting enables you to check. Typecasting is also checkable. De-initializers we can have. Reference count we have. I will explain each and everything whatever we have declared here. Syntax is same. Class name, properties and methods. Structure name, properties and methods. This is a little confusing example. We have created our own structures and classes. Structures can have properties and methods. Similarly, classes can have properties and methods as well. Creating is simple, same. Creating is same for both. If you do not assign a value, you have to pass the value. If you have assigned values, here I have assigned the values. Resolution assigned, false is assigned, 0.0 is assigned. Here name is optional. We may or may not pass. That is our own thing. So we can also simply call without values. Accessing structure variables. How to access structure or class variables? Structure name dot property name equals some value. We have printed and we have assigned the values as well. Example, my custom data type, which is having 3 properties here and 1 method. How to create the data type? Let a star var something some variable name, my custom data type, and pass the values whatever it is required. Here it is required integer, character, and string. Here we are passing integer, character, and string, and printing it or calling method. What is this? As a general consider creating a structure when one or more of these. Yeah. In interviews, they will ask you when to create classes and when to create structures. Okay. Basically, to hold the information, then go for structures. To hold information along with perform some operations, go with classes. That is the thing. Difference when do we use structure? Structures are useful to create a model class. Actually, going forward, we see model classes to create. For the data representation, go for structures. For the data representation, go for structures. That is a simple thing. Structures with custom initializers. We can also have initializers for structures as well. We haven't created initializers because we tried the other way. We can also have initializers similar to classes. Okay, these are two different ways. We are having multiple initializers. This is empty initializer. This is with input arguments initializer. Initializers are methods only. Initializers are methods only, but which has no name. Init since it is init, we simply pass the values instead of calling init. These are called constructors. Mutating method we see. Yeah, basically today's session is just to give you what is structure, what is class, what is the purpose of that, why do we need classes and structures, what are the benefits we have. Tomorrow we see some other structures and classes. Thank you for watching. Please do like and subscribe.